Greetings everyone. Today we'll be seeing the topic construction of cycloids from engineering graphics. I am Balaji M, Assistant Professor in the Department of Civil Engineering in SRM Mathai College for Engineering and Technology. Cycloid. So cycloid is basically the curve traced by a point on the circumference of a rolling circle along a straight line. So if we can consider a circle of any diameter and locate a point on it, so the path traced by this point when the curve rolls over a straight line will be a cycloid. For example, if this point is rolling over this straight line, then the point chooses a path like just like this, and it'll end right here. So this particular curve is called a cycloid. So these cycloids can be seen in many places in our day-to-day life. For an example, if you can see a bicycle moving along a straight line or a straight road, if you just locate a point on the bicycle and follow it, it will trace a path which gives a cycloid. See, these cycloids are applied in various places, such as for construction of bridges and architectural designs, because cycloidal curves are designed for greater strength and have an effective weight distribution when compared to others. If you can see the bridges over certain rivers, you can see the arches which are being constructed below the bridge, below the roads. So those arches are nothing but cycloids. So there are two types of cycloids. One is epicycloid and one is hypocycloid. Epicycloid is a curve traced by a point on the circumference of a circle which rolls along another circle outside it without slipping. So basically, which means if there is a circle, if there is already a circle and another circle is starting to roll over this particular circle outside it, which is outside this circle. If it rolls outside it, the curve traced by the path traced by the circle gives a curve which is known as an epicycloid. So in this case, if you can see, this is the uh, this is the larger circle, and the smaller circle rolls over this circle, forming a shape of a cycloid which is known as an epicycloid. In case of an hypocycloid, the a circle rolls inside the outer circle. So which means a hypocycloid is a curve traced by the point on the circumference of a circle which rolls along another circle and inside it without slipping. So if you can see, another circle is going to roll inside the circle. So if is it visible? Yeah. If you can see, the circle rolls along the inner direction of the circle. So a curve, if we plot a point like this on the circle, the path traced by this point will be like this. So this gives in the case of hypocycloid, this gives the this gives the path of the circle traced by the inner circle. So this red line gives the hypocycloid, while in the first case this line gives the epicycloid. So for the construction of a simple cycloid, let's take an example. A circle of diameter d rolls over a straight line. So we have to draw the path traced by any point on the circle over the straight line. So let's consider a circle of diameter d, and we'll start off with drawing the circle of diameter d, so which comes like this, and after which we have to divide the circle into 12 equal parts. So for dividing the circle into 12 equal parts, we need to divide the total interior angle 360 divided by 12. So if we divide 360 by 12, we get an angle of 30 degree each. So to start off by dividing, we have to draw uh, two perpendicular lines inside the circle, which passes through the center point of the circle, and after which each point is marked from the center line at 30 degrees. So a line 30 degrees is drawn here, and from this line another 30 degree, or a 60 degree from this line, from the center line is drawn. So this will equally divide. So we can extend this line down here and this line down here. So this we have divided this we have divided this particular quadrant into three parts, and this particular quadrant into three parts. So similarly, we'll be dividing the left side of the center line. So a 30-degree line here and a 30-degree line here. So we'll be divided. So if we can see now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the circle is equally divided into 12 equal parts at 30 degrees between each. So that we can see with these lines. And after which each of the point on the circle is denoted with a number starting from 1, 2, 3, 4. Do it in an anti-clockwise direction, because the ball is going to roll in a clockwise direction. So the markings are done in an anti-clockwise direction. After which horizontal lines are to be drawn from each of the point. You can use your drafter and place the drafter at a perpendicular point on the points, and draw lines such that each of the line passes through it. Each of the points have lines passing through them, just like this. So I'm drawing roughly on freehand. So you have to use a drafter, and you have to drop horizontal lines like this. If you can see, the lines will come out like this. And for the baseline, we have to we have to take a distance of pi into the diameter of the circle. And you can see, we have drawn a baseline of distance pi d, and this baseline is to be divided into 12 equal parts, just like we did for the circle. So in order to divide the line into 12 equal parts, we draw a 30 degree line below the baseline, and we join the distance of the 30-degree line is up to our wish. So we can even take 12 mm 120 mm line, and then to start off with, you have to connect the last point to the end point of the pi d line of the baseline, and then use your drafter, and without changing the position of the drafter, draw perpendicular lines to the baseline. So draw parallel lines to the baseline from the 30-degree line, just like this. So if we can see, the outcome will be like this. So after getting this, we have to we mark the points, and from those points we draw perpendicular lines to the up to the center line of the circle. So if you can see, the lines come out like this. After marking this, each of the points are marked from C1 up to C12. So after marking these center points, with the use of a compass, take the radius of the circle and place your compass on this C1 point and cut an arc in the first line. So as it is C1, the arc is cut on the line passing through the first point. So the arc starts here. So then take the same measurement and move to the line C2 and place your compass there, and with the same measurement of the radius cut an arc on the second line, and continuously go to the third point, which is C3, and cut an arc here. Similarly, for C4, cut an arc passing through the cut an arc on the line passing through the fourth point, and for C5, correspondingly on the fifth on the line passing through the fifth point, and so on. So we'll get points like this in a clockwise direction if we move, and we can see the arcs are cut from here and will go here, here, and will end here. So on a whole, if you can see, we have to we have to draw a line starting from this base point, passing through all the arcs. It should be a smooth curve. So take your pencil and use your pencil and draw a smooth curve such that the curve is smooth and as doesn't have any breakage. So we'll obtain a curve which is just like this, and darken this curve, so as this is the final curve that is to be obtained. So let me just revise it once more. We start off with drawing a circle of a known radius, and then we divide the circle into equal parts. So the interior angle is 360 degrees. So we divide each of the line up by 30 degrees, and we obtain 12 equal parts with 30 degrees between them, and after which we draw a base we draw horizontal lines passing through each of the points. So from each of the points, using a drafter, we place the drafter on each of the points, and we make sure the lines are perpendicular to the points, and after which a baseline of distance pi into d, which is the circumference of the circle. This is due to the fact that the point on the circle traces a path that starts from a particular point 1 and ends at a particular point 1. So the total distance covered by the total distance covered by this curve will be equal to pi d. So that is the reason behind choosing the line pi d, and after which we draw the line pi d, and we have to divide the baseline into 12 equal parts. For that, we draw a 30 degree, we place the drafter here, and we mark 30 degrees from that, and we draw a line down, and the last point is connected to the end point of the pi d line, and we after which parallel lines to this particular line are drawn at equal distances as this line is already divided into 12 parts. We draw lines parallel to this particular line from each of the partition points, and we locate it over the baseline, after which from the baseline each of the points we draw perpendicular lines up to the center line of the circle, and we name each of the center points as C1, C2, C3, C4, C5, C6, C7, C8, C9, C10, C11, C12. So each point is named as this, and after which the compass is taken and the radius of the circle is uh, is measured using the compass, and then the compass is placed over this particular point, and an arc is cut at is placed on C1, and corresponding an arc is cut through a line passing through the first point. So similarly, another arc is cut by placing the compass at C2, and consecutively display it is placed at C3, C4, C3, C5, etc. to C up to C12, and depending on the point it is the compass is placed, the arcs are cut the arcs are cut on the corresponding lines, and after which we use a 2h pen we use a HB pencil, and we finally trace or the we finally we finally connect all the arcs cut by the compass, and we obtain a smooth curve, which is the path traced by the point on the circle, which is and the final curve is known as a cycloid. Thank you.